Though you look like twins today, you're not twins. You're not related. You come from pretty different backgrounds and have very interesting backgrounds, not just in AI and ed tech and robotics. So I'm curious, just to start us off, can you walk us through the journey of how you came together and how you decided to build Chroma?
Jeff's looking at me because I always answer this question. Basically, the founding story is Jeff and I met in 2018. I had come to the US from grad school in Germany to work for a robotics company. And basically, when I arrived in the Bay, I was like, oh, okay, well, now I'm in the real place. I'm going to see what's going on. So I emailed or Twitter DM'd every single YC founder in the previous 2 batches that was doing anything with computer vision or robotics. And Jeff is one of the people who replied. And sort of, we started chatting and hanging out and, started having good social time together. And I think that something like—
Good social time, key.
I don't know, my brain, I've been writing a lot of code today. But I think something like 70% of every conversation we've ever had has been about why build a company? Who do you want to build a company with? How do you want that work to look like? And I also ended up doing some contract work for Standard Cyborg in 2020, right during peak pandemic when I was stuck in Australia.
And that was Jeff's previous company?
That was Jeff's previous company. And then, yeah, when we had the opportunity to work together in 2022, it was kind of a natural fit. So.
Yeah, I mean, Anton and I had both spent a bunch of time working in applied AI in various contexts. And this is back in the days where the common phrase was machine learning happens in Python and AI happens in Microsoft Excel. And times have changed. I think I'm almost comfortable saying generative AI, but it still feels a little bit dirty, I'm not going to lie.
It's like anything that works. It's just going to end up being called AI. Wow. Right? We're going to drop the generative. And then it's like smartphone, eventually just becomes phone.
Yeah. So we both worked in applied AI, a bunch of deep learning stuff, and had seen really just how difficult it was to build like reliable production systems with these primitives, right? Like conventional code, it's pretty easy to write a program. I mean, relatively easy to write a program. And you can have a large degree of confidence that it's going to do the same thing every time, given its constrained inputs. But building software systems of any kind with deep learning, generative AI, does not have that feature. You think it works in the lab, and then it gets mugged by reality in the real world, and then you're like, crap, we have to make it better. What do we do to make it better? And I think this has always been a big problem in AI is how do we make it better? I guess we give it more data and hope and pray that it actually gets better. And sometimes it does, and sometimes you get unintentional regressions and just whatever, it sucks. And so this is a pain point that Anton and I had both felt viscerally and felt that there had to be a better way. We were both really fascinated by latent space, embedding space, sort of like the place at which like data meets AI. And
my specific example of feeling the pain is I have a very specific mental image and like a visceral body sensation of being one of probably 24 robotics engineers staring at a log during lunchtime, trying to understand why is the vehicle not behaving the way we expect and searching for what is it that the models are doing wrong exactly. And this would just happen over and over and over again without any data-driven way or like really even explicable way of what to do about it. You sort of speak to the model or MLE team and they'll be like, maybe more data, which is not good enough as an engineer.
So about 18 months ago, we decided that someone should really do something about this, and I guess it had to be us. And so we started the company. And of course, this is before ChatGPT and before Stable Diffusion. The timing was fortuitous, obviously. Let me tell you, way more people care now than they used to care last year, which is cool. And yeah, I mean, I think our thesis has remained the same from the get-go, which is this is a new way of programming, and you need to be able to program it and help regulate and define its behavior. That was true last year and it's true this year. So.
Did the rise of ChatGPT change your product roadmap at all?
Significantly. Chroma actually started as the backend for those machine learning oriented products to help people build better models, to help them understand their performance and their behavior. And to do that effectively, we needed a way to store, manage, and perform computations over latent space, over embeddings, right? And we sort of, when we were building the initial system, we all needed something that we could easily deploy to our users, which they could just simply install. Like, none of the users of those products were ever going to install some giant piece of infrastructure just to use our product. So we had to build something ourselves. And then when ChatGPT came around, we realized that this backend that we had built for our products was actually generically useful for all kinds of people building with AI for the first time, because just many more people can build with AI now than were ever able to before. So we extracted that backend, we wrapped it in an easy-to-use API. It was already very easy to deploy, and that's what we launched with. Yeah.
I think most people here have some sense already, but kind of just on a basic level, how does Chroma work? And what is it used for these days?
On a basic level, the core of Chroma, of course, is why we're known as a vector database, although I actually think of it as much more than that. But the core idea is pretty simple. In order for data to be useful for AI, it needs to be represented according to its semantics instead of its structure. So under the hood, we have a few components. The first is an embedding model, which transforms any data modality. Right now, it's mostly text, but also images and audio and video are coming very soon. As soon as the models can understand them, we can use them. Thank you, ChatGPT. GPT-V is released now, so we have something releasing for that very soon. You use the embedding model to represent the data as a vector, as an embedding. And the structure of that embedding space reflects the meaning of the data that you feed into it. And so typically the way that this is used is a query comes in, you embed the query using the same model, which makes the query a point in the same latent space. And then relevancy, according to semantics, nearest neighbors, things that are related to one another, will be close to each other as points in that representation. And so Chroma essentially makes that entire process extremely simple. We retrieve the related neighbors, we retrieve the related documents so that the developer can then find the use the retrieved related documents along with the query to populate the text window and have it perform a task or answer a query using that data specifically. So another way to think about this is, rather than using a large language model as a memorizing system that remembers facts, you use it as a reasoning system that processes data. And I think that's actually a lot more powerful.
And then I'm curious, you guys seem like very different people, but seem actually very compatible and like a great group, a great pair of founders. How did you guys figure that out, of like whether or not you were a fit, and how do you guys work together?
You can answer that one.
You usually answer this.
I'm answering too many questions. It's your turn.
I think that everybody has in the back of your mind that list of people who I might want to start a company with. Maybe not everybody, but I certainly did. And I think Anton, cover your ears, but Anton was the top of my list. So I think.
Am I still top of your list?
Well,
any regrets?
That's for later. I think we have certainly we have a different energies, but a shared temperament maybe is one way to put it. I don't know. I think we see the world in many ways the same lens. We both have a lot of shared interests outside of vector databases, surprisingly. We just get along pretty well. I mean, honestly, obviously most startups die due to co-founder drama and breakups, and it's really dramatic and bad. And, thankfully I've never had that situation myself, but I've certainly had many friends who have. And, so far, I don't think we've even raised our voices at each other. So
no, I would be very surprised if we were ever compelled to do so.
Yeah,
unless it was there's a bear chasing you, or a similar situation.
One thing which is not always true, and obviously I don't want to jinx it, but I feel like once you've kind of been in the game for long enough, you don't really care about your own ego, and you don't really want to be the star of the show. You don't need to prove to the world how smart you are. You just want your thing to be successful, and you want people to use it and love it, and that's what really matters. And you kind of kill your ego to do that. And so I don't know. I think we're doing that, maybe, hopefully.
My ego got killed by my first startup.
Yeah, exactly.
Going back to Chroma for a little bit, I think Ali showed me a tweet from Andrei Karpathy earlier about kind of a weekend hack that he put together using some kind of retrieval. And someone asked him oh, okay, what do you use for your vector store? And he said, NumPy.array. And I think the point is do people really need to reach for these much more sophisticated tools? Like, when is it really reasonable to use something like Chroma, and when can you get away with something a little bit simpler?
Yeah, that's a really great question, and it's one we get asked pretty frequently. The reality is that a software engineer that's sufficiently smart with enough time on their hands can build pretty much any software. That's kind of the beauty of software. I think, so the first place where you want to use Chroma is when you're starting to manage data at real scale, where brute force retrieval is no longer practical for a variety of reasons. And what that scale is changes from application to application. But in a setting where your data is static, it's maybe like 10,000 vectors, you probably can just do a NumPy array and a matrix multiplication and get your nearest neighbors by brute force with every query. But the part where you want to start using something like Chroma is first when you're scaling beyond that, when the approximate nearest neighbor search actually starts to matter. So for us, that's roughly beyond 10,000 entries of, say, A to 2 scale vectors. Okay, here it's going to start chugging if you're just doing brute force. So you might want to adopt an approximate nearest neighbor approach. Of course, you could just grab a library and implement this yourself, but we've done it for you, so you might as well just use us. And we've got a lot of developer affordances as well, like we manage your embedding function for you, we manage the actual document retrieval for you. So if you want that simplicity and to just get on with application development, we do that for you as well. But there's other parts to this too. The other place where you might want to start using Chroma is the fact that we keep everything up to date. You don't need to build all the plumbing or the infrastructure to do it either. So even if you have, in any given collection, a small amount of data, you might be, for a user application, user-facing application, I should say, be creating indexes and collections, deleting them, modifying the data in each of them all the time. We have all that plumbing for you. So from that perspective, it's about developer convenience. Now, the next part beyond that is scale, as I mentioned, and our sort of distributed open source data plane is coming very soon to allow you to scale horizontally. Current single node Chroma scales up pretty well as long as you have enough RAM, but memory is expensive, so distributing it over multiple nodes makes sense. And then going beyond that, and this is kind of in my mental model, is going up the adoption curve. The thing that you need to actually make a retrieval system work in an AI application is a lot more than just basic vector search, right? And the example that I like to give, and many people have heard this before, but imagine you take the English language Wikipedia entries for birds, right? And you get them and you embed them and you stick them in your vector store. And you're fine as long as all the queries are somehow related to birds. But if a user eventually puts in a query and it's about fish, you're guaranteed to get 5 nearest neighbors, but you're also guaranteed to get purely irrelevant results. You as an application, like how do you handle that as an application developer? In a traditional database, okay, no results found, I have a code path here, I've recognized that that's happening. In semantic search and retrieval, we have to raise like a relevancy score. We have to give developers a probability of the relevance of the results. And that ties into all kinds of other pieces of the retrieval system. How do you select your embedding model, right, for your data, and importantly also your use case? People forget that this is actually conditional, not just on the data set, but the use that you're trying to put it to. How do you decide how to chunk up your data so that the retrieved results are actually not only relevant, not only semantically correct, but actually processable by the model as well, right? That's an important and often overlooked component. And then how do you include human feedback back into the model, right? Like one of the great things about AI is you can turn a static piece of data into an endlessly adapting data engine by incorporating feedback from your users, telling you, okay, this is good, this is bad, this is working, this is not. All of these are part of the stack that we're building, right? And our aim ultimately is AI application developers shouldn't have to think about their retrieval system. It should work out of the box as well as possible so that they're not fiddling with all of this. I don't know how many of you guys were at OpenAI Dev Day, but they gave this great presentation and they were like, yeah, here's how to do this. And they gave like a part of what you need to do to build an AI application, and they had promoted RAG as like a key pillar, which was very great for us. And they were like, yeah, we built this RAG system, here's how it works. We went through 50 iterations of that. And it's like, well, maybe OpenAI in their kind of product-y, researchy org can do that, but an AI application developer is not going to go through 50 iterations on their retrieval system. We need to just deliver that. So.
Okay, so that makes sense. Some people need out-of-the-box solutions. There are other out-of-the-box solutions. There's other open source ones like Weaviate. There are closed source ones like Pinecone. There are databases that are adding vector search. How do you differentiate yourself from all of those other options?
I think in general, I think everybody's good intentioned and working hard and, serving hopefully their users as well as they can. So we generally avoid sort of making direct comments about what other people are doing. But I think that For us, we just really care about serving the developers who use Chroma. Like if you post in Chroma's Discord, you will get an answer in like 10 minutes. If you post a GitHub issue, you will get a reply. Definitely within 24 hours, probably faster. And I think this like obsession with supporting developers in building their applications and getting them unblocked. And by the way, any feedback that we get in Discord or GitHub makes the product better. Like we integrate that very quickly into the product. And so this is what we're focusing on. Obviously, we also really care a lot about developer ergonomics and experience and trying to make this stuff as easy as possible to use and learn. And I think it shows in the numbers. I don't know, like, you know, I do pay attention to the numbers, and the numbers are good and really good. I think that actually, you know, again, not to name names here, but for one naming name, like the past couple weeks, like Chroma's had more PyPy downloads than Pinecone many of the days. And so, you know, we've had now millions of developers use the product and love it. And that's insane to say out loud. I don't really know what that means, and I don't know how to process that, but it's this really cool thing. I think it feels insane just because we just haven't, like, we're not like a marketing machine. There's no content calendar.
This is our marketing.
Yeah, we're not. Yeah, so this better go viral. No, but we're not doing, you know, tons of webinars online, and it's just not really our style. But I think people have like found it and loved it. And so I don't know, like, yeah, lots of other people are doing stuff. People love Chroma, and people love the developer experience. And as Anton mentioned, you know, the first thing that we did well was developer experience. The second thing we're going to do well is distributed and hosted. And then the third thing we're going to do well is all the other features that developers need to build these like production applications quickly and easily. And we feel like we just got to keep doing that.
To sort of expand on the technical side of this as well, and I agree that like one of our big differentiators, especially early on, was just our ease of use and developer experience, right? Chroma actually enabled a bunch of other open source projects because we were the easiest thing to integrate, which made their projects very easy to deploy, right, and demonstrate the power of their work. I'm very proud of that. I'm actually one of the proudest things that I've been with Chroma is we have started to appear in AI research papers as sort of the memory in the data store, right? There's a few out there.
Yeah. Which ones we can take a look at?
Voyager, for example,
Yeah.
the one from NVIDIA Research, the Minecraft playing bot, it uses Chroma under the hood, and we didn't coordinate with them at all. They just chose it because it was the best thing, and that's very gratifying. From a technical perspective, right, Chroma, many of the other solutions that are out on the market today were built over the last 2 or 3 years, and these companies have been around for a little while. They were built specifically for the use cases of recommender systems or web-scale semantic search, right? Contrastedly, Chroma has been built from the ground up specifically for AI. And there are specific technical trade-offs that we have to make in the way that the index is built, in the way that we manage indexes, in the way that we scale, in the fact that we have to, you know, a significant fraction of all the data in a Chroma collection being used in an AI application is being updated rather than a small proportion of it in a batch update interactively. All these pieces, right, they end up mattering, and they end up coming together to just like, make it just work, right? Where, as opposed to adapting something that's built as a recommender system for this AI use case, just because it also happens to store and query embeddings. That's a big difference.
Yeah, so speaking of those differences a little bit, you also mentioned the OpenAI Dev Day and everything, right? And I think there's a lot of excitement about agents. So what are some of the kind of things that you see in particular for agents that will be really useful that you're building into Chroma, kind of looking forward and thinking about that?
Yeah, I think agents are probably like the first AI native use case that I can think of for AI as a software stack. Don't get me wrong, being able to interact like non-linearly with a large corpus of text and chatting with your documents is great. It's very valuable. It's very, like, I use it for a variety of things, but agents are like autonomous systems that you can use in very practical ways. Chroma is really built for the agents use case, and Voyager is already a great example of this, right? And the fact that we support interactive updates, the fact that we have metadata built in, all of these features just allow you to just plug this in as your agent's memory, and then you can have a bunch of agents running on the same Chroma system as well, right? Either independently or all working on the same data. One great example of this was actually we did our Hacker in Residence program a little while ago, and one of our hackers built, I forget what it was called, but it's a system where it's like that Stanford paper, the Agent World paper or whatever it was called, but instead of having like a game simulator doing like iterating and responding to the agent's actions, the game world itself was also an LLM using retrieval under the hood. So you can really build these like multiply interacting systems all on top of the same retrieval system because of the way we've built Chroma, right? It's multiple independently scaling, independently operating indexes. And then of course on top of that, all of the things you need to actually build robust agents on top of your retrieval system come built in, like things like relevancy, things like feedback, things like auto-updating the data, things to make sure that the actual retrieval results get better over time. These are all built into the product. I'm very excited about agents.
Curious, looking to the future, Jeff, you recently tweeted that your aim is to program AI with data. What did you mean by that? And more broadly, I think you've alluded to some stuff that's coming soon, but what does the future hold for Chroma?
I'm glad these are Jeff tweets that are being revealed on stage.
Here's where less safe for work.
Yeah, I'm not sure if that's like an official company tagline. So, but I can tell you what I think it may mean, and it might be cool. I think, listen, like whether artificial superintelligence comes and whether GPT-7, you can just feed it bioarchive and it'll cure cancer, I don't think anybody knows. I don't think even OpenAI knows. But, this stuff is pretty valuable. It seems to be, getting more valuable, more useful. And, it would be great if it was reliable. It would be great if you could just build a system that did what you wanted it to do, listened to your instructions, didn't go crazy. That would be nice. And so I think one theory of this is that there will be an emergence of LLMs that are focused on reasoning. This is not pandering. But LLMs that are focused on reasoning. And okay, that's great. They're good at reasoning. You need to still supply them the right information. And I think that's kind of retrieval's stance. Retrieval today is very rudimentary. Like the fact that we do retrieval one time per generation, the fact that we only do retrieval via natural language English, the fact that retrieval is really not at all like a part of the model architecture. It's like a completely separate thing. We just think that all of these things are like caveman. This is like we're running around with clubs right now.
We're rubbing sticks together to make the AI go.
Yeah, exactly. And all of that will get better. And again, I think back to what was it like to build, we're still doing this on a daily basis, but what is it like to build software with code? You have some confidence about how the thing's gonna run. It's programmable. You have an idea about, okay, I'm gonna change this thing, and I have some idea about how it's gonna change the behavior to be more the behavior that I want. And I think that that is a full set of tools there that need to exist to help AI developers do the same thing. And I think that it is very data-centric. If you think about the path here, input comes in, it gets some context, it goes through the weights, out comes your generation. It's as simple as that. And okay, great, what can we change? We can't change the input or the output directly. We can change the context and we can change the weights. How do you change the context and weights? You change the data. You change the data that's in the context window somehow, and you change the data that's been put into training or fine-tuning. And so, it feels like a shtick at some point to say that it's all about the data, and people have been saying this for a long time, and in many ways they've been wrong because actually unstructured data went a lot further than people thought it was going to go. But I think you still can't get away from the fact that a small set of well-labeled data can make a world of a difference. And today we don't see a lot of fine-tuning going on in models. A lot of people are just picking up these large models from OpenAI and others and just using them directly. But I think as more and more use cases go to production, you'll see more and more fine-tuning. And so obviously today, Chroma mainly talks about data for retrieval. We suspect that a lot of the same interpretability tools that help you select data for the context window will be the same set of tools, or very similar, that's used for selecting data for fine-tuning. And so we just have a big vision of it, not because it's cool to have a big vision, it's because we just care about solving the problem. This is the problem that Chroma got started with. Hey, it sucks to build stuff with AI. It's really infuriating. Wouldn't it be nice if it wasn't? And wouldn't it be good for the world, right? There's lots of the possibilities of good things that AI can do in the world. And it just seems like it would be better if that was easy. So,
To take another tack on that, actually, the big question right now is, can we build robust production-ready AI applications? Can we make them run stably? Can we expect that they'll actually perform the task at a reasonable rate? And again, this is exactly the same sorts of problems that we set out to solve, just in a new domain. And it's really funny to me when people ask, Anton, why did you pivot into building a vector database from being a roboticist? And I'm like, no, it's exactly the same set of problems.
Josh, as someone who is building models optimized for reasoning, what do you think?
That sounds right. Yeah, I think my question actually is, what are the things that you guys are looking forward for other people to build, not retrieval? Like, what other capabilities do you think academics, other startups are going to build that you're really excited to see happen out there?
Yeah, so obviously one of those is the reasoning models themselves. We're very excited to see how we, as Jeff mentioned, how we can plug the retrieval system directly into the inference stages of the model. But beyond that, there's more prosaic stuff. One of the things that I was most surprised about at OpenAI Dev Day as well was they didn't release an evaluation platform. They recommended like a couple of okay open source ones. I'm actually really looking forward to the proliferation of these tools. For one reason is because we can plug Chroma directly into them and then automatically improve your retrieval system because we're getting those evals back. I think monitoring will also shortly come online. I'm not sure if it's like the right time for it yet. I think when we start to be able to measure the ROI out of these applications, those kind of like business level things. And then I think what's important and what's so great about AI is it's very, very accessible. Right? You no longer need your own GPUs. You don't have to be part of a lab or in an industry to play with this technology. Literally anybody can like try to get a new capability out of the existing models. And so the thing that I'm most excited about is that exploration of that use case space and see what actually works, what doesn't, where we can improve. But like, I think there's going to be a lot of surprising stuff. And that's part of the fun of building open source is we get to see what everybody else is building, and we get to be surprised by how things are getting used. And I guess that's really what I'm looking forward to. I think that people should continue to explore the possibility space of the applications that can be built, right? Because when you say, okay, this is a very useful application, what do I need to do to actually make it work? Then we figure out the tools, then we figure out the platforms. It's a mistake to kind of place a bet too early on, oh yeah, like these are the use cases that are definitely going to be huge, although some of them already are. But that emphasis on exploration, I think, is really important.
I think two things. I would echo eval. I think it's really important. The other thing I'd add is I think that once we have really good, probably open source, with language as well as vision models. I'm thinking of like Lava, Baklava. I'm thinking of Mistral 7B. Like once these things can take advantage of like the latent compute sitting in your pocket or sitting on your desktop and being totally privacy preserving, I just think that's going to unlock like the same creativity that went from when you were at time sharing in the early days of databases to you had a PC on your desk and you can just use that thing all day long and it feels free in a way. I think that shift is going to be really important for consumers and you'll see a lot more like really cool stuff.
For business too. For business too. I mean, there are tons of use cases even inside Chroma that we've been batting around where a tiny open source task specific model can really do a lot for our system. Right, and so to echo Jeff's point, I think actually the push to open source and then the understanding of how do you specialize these things is also really important. Like more understanding of like how do I actually make this thing specialized and work.
All right, with that, we will open it up to questions.
That's a really good question, and even like I think it was today that OpenAI put out that call for like specialized data sets, and you get something from it. I think. The large models have been trained on pretty close to all the tokens that there are at this point. I think the open question remains is how do we get other types of data to work with these models? That's the first question, because a lot of it is specialized. For example, we've been speaking to people in kind of the biomed space doing things with molecules and proteins, and they'd really like to have the same kind of reasoning capability that we have in other domains. But it's a question of how do you actually get the models themselves to consume that data? And there's even some examples, like GPT-V is great because finally all the image data that we have lying around can be unlocked and processed by the models. So it's a combination between how do you operate with the existing models on your specialized data, and then how do you use your specialized data to build specialized models. If I was to predict how this would evolve, I mean, I don't think it's a unipolar world, right? I think that ultimately things specialize, and they specialize for particular reasons. Of course, if we do get AGI, all bets are off. So Chroma already has metadata filtering, but I don't think that that's really what you're asking, right? What you're asking is how do we use all of that data in a retrieval system?
Correct, but only I don't want to search through the syntax similarity of everything.
Yeah, I understand. So again, Chroma has metadata filtering built in. You can tag the data however you like. You can partition that space however you like. That is the short-term answer. right? That is the answer that works today. The long-term answer is we should be using some kind of language processing model, which may not be an LLM, it might be something else, to actually understand what parts of embedding dimensionality and what regions of the embedding space are relevant to your task and your data, right? Now, the important thing to remember is we're dealing with a geometric space. And because of that, we can perform all kinds of operations to squeeze and stretch that space and project it and fit manifolds and change the dimensionality, right? The trick is how do you do that in a general purpose way? And the way to do it in a general purpose way is to find a model who can understand the semantic content of your query or the semantic content of your intent, right? And perform the appropriate operations in the retrieval system. That's the future. But right now we have metadata filtering, so you can totally do that, or you can just make more than one collection, either way.
That's what I'm doing now, more than one collection, but I don't want to do duplication.
Yeah, that's fine. I mean, partitioning the space, or you can have multiple collections, it depends. Again, in the short term, we can construct virtual indexes as well. This isn't in the product yet, but it's something we're looking at because we've seen a few use cases like that, where we can construct virtual indexes over the same data, so it's not really duplication.
One of the big differences is in the old school world of recommender systems. You as an organization, a company, a team might have one index that was 1 billion vectors. And that's all that you had, and you didn't update it every day. You updated it once per week, and you just deleted the index, and you just rebuilt it every week. And you're at a big company, and you have a lot of compute, so whatever. It doesn't matter if it's expensive and slow. We'll just throw compute at the problem. And this is just the world that existed, right? And so people built products to serve that use case. What we see with application developers building use cases for AI is, yeah, sometimes they have 1 billion vectors in one index, but more often it's anywhere from 10,000 to 10 million. That probably covers the majority of index sizes. So that's number one. Second of all, they don't just have one index, they have tens, hundreds, thousands, tens of thousands of indexes. I think it probably makes sense, going back to the question about agents, it makes sense for every agent to have their own index and their own collection, and that kind of makes sense. And so you want them to be cheap, right? You want them to be free. You want to easily be able to create them en masse. And a lot of the other systems don't handle that very well. A third and last thing that I'll mention is existing recommender systems teams had whole teams who were dedicated to, maybe not whole teams, but at least individuals, who were dedicated to understanding the recall performance of the index. And so as you go from known nearest neighbor, which is brute force, to approximate nearest neighbor, there is a loss in quality. It makes sense. You have to make some trade-offs. But how big of a trade-off are you making? People don't have any idea today, generally speaking, for building AI applications. So this is something that we really want to bring to the product. Actually, the last thing that I'll say is batch versus dynamic updates. In recommender systems, again, you just tear down the whole index, throw in a ton more data, re-embed, re-index the whole thing once a week. With AI developers, what we're generally seeing is they don't want to have to think about that or reason about that. They just want to be able to continually add, update, and delete data and still get good performance out of their system.
Well, because a lot of the time that data is coming in interactively online,
yeah,
right? And that's fundamentally different to the Rexus use case. To answer the question regarding how I think the future is going to evolve, again, I have to say that it means putting more intelligence down in the data layer, right? The tasks that we're attempting to perform, the whole point of AI is that we can reason about information semantically. And so that means we need to add more of that kind of representation. We need to reason about the data semantically as well, not just at the point where the generative model is performing the task, but in how we're representing the data itself to feed into the model. And again, that speaks to Jeff's point. The generative model, the LLM, and the data store are covering similar territory in terms of the problems they want to solve around data. And we think that over time, these two things will merge more and more. And we're seeing increasingly relevant, increasingly interesting research in that direction. That's where I think things will go, right? Instead of taking a document, putting it in the model's context window, you'll feed it information directly into the layers, right? Because it's already represented in a vector, and internally to the model, it's also represented as a vector.
I think what I would say is, if you haven't already, go download Ollama in 20 minutes or less, 10 minutes, 5 minutes, depending on your internet connection. You can be running Llama 2 on your laptop, you can be running Mistral 7B, you can be running all kinds of cool stuff. So Yeah, that's probably what'll happen, I guess. I don't know. Do you have an additional? I don't.
Yeah, no, I want to add to the way to think about these things, right? You can imagine having a device, and there are a few of these projects in the world today that has access to your personal information, and then you have a retrieval system running locally on your device that plugs into services, right, that you want to interact with. So you have your kind of local homunculus, which is a word I really like, which represents you when it interacts with all these other services, but ultimately you still keep control of your data. You decide where it's going, and that's a way to do that is by have everything running locally on your future device, whatever that happens to be. We're seeing a lot of these really interesting ones come out lately. I mean, we're seeing some really cool stuff. I'm glad that people are experimenting with hardware. I think the interesting thing about hardware is you can stock it with a whole bunch of sensors to have it, understand the real world and eventually start to reason about the real world. Now, the really kind of the strong version of hardware is robots, of course, right? It's turning the AIs into embodied agents. And again, anytime you're using AI built on this type of platform, you need a way to get the right data to the model, essentially, right? And I think that ultimately retrieval has a part to play there as well. In terms of kind of like the personal devices that have come out, I think they're really interesting. I think there's tons of like gadgets and form factors and things to try, and people will put these things eventually into vehicles and into entertainment devices, and I'm pretty excited about a lot of these things. Again, like the things that I'm excited about is the fact that really you can't predict where all this is going yet. And it's fun to be in the Wild West, It's fun to ride the tiger.
I think one mental model here, obviously hardware can mean anything from like chips to consumer devices, so different ways you can take it, but I can kind of easily, maybe you don't want to talk about, Kantian philosophy with your laundry machine, but it would be nice if your laundry machine remembered your preferences at a minimum. And so I feel like it's sort of very likely that intelligence too cheap to meter will run in almost every product experience that we have in not that long of a future.
That's really the big hope of this age of AI, I think, is actually that phrase, intelligence too cheap to meter. That would be wonderful because we'll put it everywhere that it's useful. And that's a future worth looking forward to. Cloud-hosted Chroma is the #1 thing everybody asks me for. They ask me for it in every possible communication channel. I'm pretty sure someone asked for it on the Partiful invite to this event.
And the answer?
Yeah, I mean, so besides cloud, of course.
Cloud and hosted are two things, technically, I think, right? Distributed Chroma.
Yes.
Cloud, hosting Chroma, that counts for two.
That's okay, fine. But in terms of product features, it's the sort of stuff that I talked about in terms of advanced retrieval. Beyond the kind of infrastructure piece that makes the vector search capability work really well, things like, again, the feedback endpoint, multimodality, like smart chunking, these are all things that we get regularly asked for. These are things that people start to want when they're a little further up the adoption curve of this technology. And that's typically they have a system, it's operating as an experiment, it's operating reasonably well, they want to roll it out, but they need knobs and levers to improve it continuously over time. And so those product features, I think, are actually really important. And we can build them because, again, we're an AI native company. We only care about AI application development. There are millions of features and products that one could build on top of an embedding store, and we experimented with some of these at the start of the company. But we're laser focused on those AI application developer use cases. Yeah, so I don't want to compare OpenAI's tool to LangChain or really other open source frameworks. I think the real great thing about custom GPT is it educates developers in how to build AI applications in a very simple way because it comes with everything you need automatically built in, right? So if the best thing that OpenAI could have done on Dev Day, and it's exactly what they did, is find ways to onboard more AI developers into the ecosystem. I think that that's incredibly important, and I think that tool is great for doing that. Right now, the retrieval system in custom GPT is honestly very limited, and it had some performance issues on launch. Those things are going to get better. They've got some good infra engineers over at OpenAI. But I think it's one form factor for application development in a vast ecosystem, right? And ultimately, I think it's just a good thing to have this thing available and give people a way to build with it.
Yeah, so there's a few different things that people mean when they talk about fine-tuning embedding models. So one thing they mean is fine-tuning the embedding model itself. So you're changing the semantic expression and capabilities of the model. And that's, I think, quite appropriate for domain-specific things. So legal domain, healthcare domain, these sorts of things. It's sort of like how I think about language model fine-tuning. It's teaching the model how to think. And so if you want to teach the model in ease, like doctorese or lawyerese, it's a different way of thinking, then maybe fine-tuning is a good thing for you to do today. Again, this will all change in the future, but that's kind of, I think, today's reality. That's also true for embedding models. Now, there's a second thing that people mean when they say sometimes fine-tuning embedding models, which is giving the model, giving your embedding space feedback about, hey, those 2 points should be closer together, those 2 points should be further apart. That's the simplest way to plug it in. And then there's different ways to think about it, but it's a map, right? And so you're taking the map and you're squeezing the map and you're twisting the map and you're shrinking the map. And in so doing, you're pushing results that should be closer together, and you're pushing results that should be further apart. And it's a way to increase the performance, of your existing embedding model. It's also quite attractive because it's easy to do online, it's very cheap, it's reversible, it's just has all these benefits, it's very interpretable, has all these benefits which I think are quite nice. And so the latter is coming to Chroma quite soon. The former, I don't know that, I'm not sure if Chroma will support that directly. We do hear from developers that they want us to run open source embedding models for them. Sort of just nice to have it server side, and that obviously extended in some other ideas about sort of running, broadly speaking, UDFs, user-defined functions. So we'll see how all that evolves. I'm not committed to doing that. We'll only do it if it's what developers want. But yeah, that's hopefully an answer to your question.
If it turns out to work, basically, that's something that we'll adopt. Our thinking around, there's a lot of noise in the ecosystem right now about different methods to try, different sort of flows in retrieval. We are about extracting the stuff that generally works for developers, and that's what we'll pursue initially. Now, going one step beyond the simple question about fine-tuning embedding models, this is a point I wanted to make. People for a long time, for strange reasons, have considered fine-tuning the language model and then fine-tuning the embeddings as kind of two separate things. And they used to think of fine-tuning and retrieval as complements to one another. You do one or the other. But actually, as substitutes, but they're actually complements. So what I mean by that is you should think about jointly fine-tuning both your embedding space, whether through the sort of adapters that Jeff mentioned or whether tuning the actual model, as well as the language model itself. There's a few great papers that have come out in just the last couple of months, and papers are actually typically behind the industry folklore by a couple of months now, so people were already aware of this. But it pays to fine-tune your target language model on the types of retrieval-augmented tasks that you're attempting to perform, and jointly use, and this is the beauty of it, you can use the same data that you gathered to fine-tune your embedding model to fine-tune that large language model. And people are seeing really great results out of that. It's unclear what part of this will do for you versus what part you'll need to do yourself, and it really depends on how things develop, but basically there's a lot of headroom to improve here, right? And we're excited about helping people get there.
All right, the questions are continuing to flow in, but we're at time, so I'll stop us there. Jeff and Anton will come and hang for a bit, so you can come. Sure, go ahead.
Chroma is hiring.
Yes,
so,
please.
If you geek out about building new data systems and running them as a service, or your friends, please come talk to us. Thank you.
Yes, also I hear some exciting announcements coming soon,
Very
so
soon.
keep an eye out. Thank you both so much for joining us for our last event of the year. Round of applause for Jeff and Anton.
Thanks for having us.